let's just get started. And as I just mentioned, today we are going to talk a little bit about the thing and the subject that we are going to cover. The whole course is about the math itself. As we all know, math is a very, very diverse, important, and also very useful topic in different kind of things that we have. It doesn't matter, it's just about the normal shopping, it doesn't matter, it's about the programming, in almost everything. And the thing that I really believe in that is that first of all we have to have a good understanding that what's going on inside the math itself. That's why I thought it would be better to have this course at the very beginning side of this channel, and after that for the next part we can have a better, more advanced parts that we can talk about different kind of topics and how we can implement the math itself. The first one is I'm going to talk about it today would be about the foundation level. So first of all, we have to add what are the number systems, what is the arithmetic, what are the operations, fractions, and decimals. After that, we are going to talk about the intermediate levels, which is talk about the percentage, the ratios, the basic algebra, geometry concept, and etc. And at the end, we are going to talk about more advanced level, which is about statistics, probability, the functions, trigonometry, and all of the applications itself. This is kind of expectation that we have from this course. So we do have, first of all, we do have clear explanations of the concept itself, and after that we do have interactive learning. It means that both of us, we are going to solve some solutions, and after that we do have some examples. It means that either it would be the practical examples or we just the normal examples that we have. It means I will give you some time during the course itself, during the video itself, and after that you have to pause the video and solve it, and after that part we are going to solve all of the solutions together, and at the end we are going to have some critical thinking that actually, so we learn the concept, so what, how we're going to use that in a real life scenario. So let's start with the first section, which is about the foundation level. So in the foundation level, we are going to talk about three important parts. First of all, we are going to talk about this number systems. I mean, about the place values, the countings, and the basic. After that, we are going to talk about the basic operations, which is addition, subtraction, division, multiplication, and more. And at the end, we are going to end this part with just a little bit of talking about the fractions and decimals, which, as I just mentioned, this part we're going to move to the next section, but at this point I'm going to talk a little bit about that. So let's just start. The number systems and basic concepts. So numbers are so familiar to us. We know everything about it. We know 1, 2, 3, 4, -1, -2. We do have half, 0.75, whatever. So these are the numbers. But it is important to know that when we are talking about the numbers, what category are those numbers be in? So it means that when I'm talking about the chain of the numbers, 1, 2, 3, 4, actually they do have a name. So let's just get started. The very first part of the numbers that we know is about the natural numbers. So obviously we all know that from the kindergarten, from the beginning of our childhood. The very first thing about the numbers that they some kind of taught us what about the natural numbers. It means that it would start from 1, 2, 3, 4 to infinite. So as you can see, there's nothing strange about that. They're just normal numbers, and after that they would start from 1, which is a very important concept. This part would start from 1 and it would increase 1, 1, 1 itself. So we do call it as a natural numbers. Easy. Another type of number that we do have is the whole numbers. The whole numbers actually are just like natural numbers, as you can see part of it, but with one addition section, which is the 0. It means that not only we are going to count from 1 to infinite, we are going to consider 0 in it. So far we have two numbers, natural numbers and whole numbers. Easy. After that, another important numbers that we have, have in our category would be about integers. So what does integer mean? As you can see over here, integer contains 3 sections. The first section is just the natural numbers. We just learned that. And we also learned that if I contain another 0 in a natural number, it would consider as a whole number. But the only numbers that we consider so far was about the positive number. We didn't talk about the negative ones. So if we try to talk about the negative numbers, as you can see over here, we just call it as integers. So it means that we do have a natural numbers, we do have another 0 for the whole numbers, and after that, on another side, we do have negative numbers. The combination of all of these numbers is going to give us a new category that we call it as integers. Again, no decimal points, just real numbers, just whole numbers, and we don't have any 1.2, we don't have negative 1.5, whatever, only complete numbers without any decimal yet. Last group that we are going to talk about is just rational numbers, that these numbers can be written as fractions. So what does that supposed to mean? Imagine that you do have a number as half. So I do have the half itself. So half is just a number. Yes, right now it's not going to be considered in any of these categories that we have. It's not going to be a natural number. It's not going to be a whole number. It's not going to be an integer. But half also can be written in fractions. So when we're talking about the fractions, I mean, at least we do have a little bit of understanding. But for the all who don't know about some kind of the fraction means that I do have a number that can be written as something like this. One part on the top, one part on the bottom. And after that, I do have a line between. Again, I don't want to get you confused. Right now, we don't know anything about the fractions. But the way that we can write down this, guys, it would be like this. It would be a, which is a number on the top, divided, which is using a line itself, divided by another number. So this is something that we know as fractions. Again, no names, nothing. So I do have a number that they call as half, right? How I can write this number? So what are the two numbers that if I divide them together, imagine the first number is A and the second number is B. What are the two numbers that if I divide them together, I do have half? Take your time, use the calculator of your computer, use the calculator of your own, and after that, if you do that, you can see that I can find two numbers, which the first one is 1 and the second one is 2. If I just write down 1 divided by 2, I do have a number that we can call it as half. What did we understand? We understood two things. The first one is that what is rational numbers? Rational numbers are the ones that you can call or that you can write them as fractions. And also, we learned a little bit about the fractions. Fraction means that I do have sets of number that can be written in this form. The first number on the top, I do have a line that I call it as division, and after that I do have another number which is the second number. If I can find a way to write down any number that I have by the division of one number divided by the second number, we can call it as what? As rational numbers. Very interesting topic. So obviously you can see that, again, we do have very, very limited knowledge about the fractions. We don't know about it that much, but I'm going to show you something very, very exciting. So as you can see, the very last number that we have is -2. So out of 4 categories that we just learned, -2 is going to fit inside which of them? Exactly. It's going to fit inside the integers. And also, as a matter of fact, why I can't consider -2 inside the integers itself? Is there any way that I can write down -2 as two numbers divided by together? In the future, you can see that yes, that is applicable and I can do that. I don't want to show you how, but I can do that. Here, let me give you another number. For example, give you number 4. So obviously 4 can also be written as two numbers, one divided by another number. And also I know 4 could be fit inside another category. What is that category? That category could be a whole number. That category could be natural number. And that category also can be integers. So fun fact, rational numbers can be written as fractions. And we all know we also can write down any number in the world as fractions. So it means that it doesn't matter what kind of number that you have. All of these categories can be considered as rational numbers. But I have to know it's not a two-way road. It means that if I consider a number, for instance, if I consider a number from natural number 1, 2, 3, 4 as part of rational ones, I cannot consider it as the natural number. What does that mean? It means that when a number can be considered as another category, it doesn't necessarily mean that that number can also be at the first category. So it would be a little bit complicated right now, but I promise you, just by passing by, you can understand the thing. So far we understand something, that we do have 4 different kind of categories right now. There are other kind of categories, but right now we know about 4. Natural numbers, which are just about 1 to infinite. whole numbers which are 0 to positive infinite, integer numbers which are 0 to positive infinite, 0 to negative infinite, and rational numbers are the ones that can be written as fractions. So let's talk about another concept. Let's talk about, let me just get rid of this part because I don't want to be messy. So let's talk about another concept, place value system. What does that mean? Imagine that I do have a number. For example, this number is 352. Listen to your voice. 352. What does that mean? It means that out of this 3-digit number, I can divide it into 3 different sections. 300. If I ask you to divide the 300 into 2 different parts, what are 2 numbers that if you multiply them together, you have 300? Exactly, 3 multiplied by 100. 300, that's why we call it. 50. Again, if you divide it into 2 numbers, what are the 2 numbers that if you multiply them together would be 50? 5 and 10. Exactly, 5, 10, which we know that's 50. What about 2? How I can consider 2 numbers multiplied by each other and it would be 2. 2 multiplied by 1. Again, I'm not expecting you guys to completely know about the multiplication. Multiplication would be for the next part. But these are the basic things. You also can do that at home. 300, 3 multiplied by 100 would be 300. 55 times 10, and also 2 times 1. So what do we see right now? You can see at this point, I do have 3 interesting numbers. 100, 10, and 1. Another thing that I know is that each of these numbers, 2, 5, and 3, based on the place in the digit system that they have for this specific number, can be valued. It means that they do, based on their place, they do have value. That's why we call it as a place value system. It means that each digit in a number has a value based on its position or its place. Number 2 is in the first position, so it only has value of 1. Number 5, it's in the second position. That's why it has a value of 10. And number 3 is in the third position. That's why it has the value of 100. So why are we going to use that? First of all, when in the future slides we are going to talk about the addition and subtraction, is that the place value system is going to be so important. Why? Because when you're trying to add 2 numbers or subtract 2 numbers from together, you have to know that sometimes you have to use different kind of place value system in order to reach to your answer. It means that there's sometimes you do have this big number and you have to divide it into different place value systems. And sometimes you have big numbers, but if you want to subtract one from another one, you do have a problem with that. So at this point, I know that 352, as we would just talk about it, it has 3 important parts. It has 3, it has 5, and it has 2. Based on each position, I would call it as a name. 300 is a hundreds, 510 is tens, and 21 is units. So we just learned that hundreds, tens, and ones or units are going to decide about the value of a specific number in a system. So what are the real life applications? So obviously it's about the shopping, it's about the phone numbers, it's about the dates, especially about the programming. You can use all of the numbers side by side together. So that was the very, very basic parts about the numbers itself. You have different type of numbers, you have the 4 categories for them, and also we learned that based on specific space of each number, we can call it as a place value system. So let's go for starting a very, very important operation that we know it as addition. So what is happening inside the addition? First of all, what does it mean by addition? Addition means that you have 2 numbers and you are going to add them up together. For instance, I do have number 2, and after that I do have number 5, and I would like to know what would happen if I add them. So obviously, in this case, it is so easy. 2 plus 5, it's 7. It's no brainer, obviously. But imagine that I do have much more complicated cases. Imagine that I do have 2 numbers like this. and I would like to add them. So obviously I cannot do it that easily. Yes, I know we do have the calculator, we do have the AI. Yeah, we can use them. It is so easy. But again, these kind of courses, or this course specifically, is there in order to improve your brain capacity. So we are not going to use the calculator that much. Yes, sometimes we have to do that, but we are going to do everything by our own. So it is important to know and understand the basics. So let's start with this part. The first thing that we have to know about the addition, by the way, this should be addition, should be fixed. Addition techniques. So the very first thing that we have to know about addition is the way that we do the addition. There are three different ways for doing the addition. The first one is about the column addition, which we some kind of, I guess we know it from the kindergarten, from the elementary school, which is about the column addition. What does that mean? It means that at this way, I'm aligning numbers vertically by place value to add digits in columns. What does that mean? It means something like this. It means that I do have two numbers, 37 and 45, based on the place value system. I'm going to put them side by side. 5 would be underneath of 7. 4 would be underneath of 3. Why? Because 5 is units and 4 is tenths. So again, it is important to know about the place value system. So this is the very first way. This is the very, very common way that we do that. And you probably 99% of the work would be like this. But we also do have two other ways. The mental math. What does that mean? It means that breaking numbers into tens and ones or hundreds or other any specific value system that we have, and then add them up more easily in your head. What does that suppose? Imagine that I do have two numbers. Imagine that right now, again, we are going to start with very, very basic, so I'm trying to be cautious about my examples. So I do have 12 and I do have 23. I would like to add these two. So obviously, the very first way that we learn is about 12 plus 23 and find a number out of it, right? So right now, let's just find another way. 12, 23. If I just divide these two numbers, each of them, I mean, if I just divide them into two sections, I do have 12, it has 110, it has unit, which is 2 units. I do have 23, it has 2 tens, and it has 3 units. So right now I can say 12, just put it this way, 12 is 110 and 2 plus 23 is 20 and 3. What am I going to do? If you see at the mental math, we are going to break numbers into tens and ones, the way that we just did it. Yeah. And add them more easily in your head. It means that right now I'm going to add similar numbers with the same place value system. So at this point, if I want to add these two numbers together, first I will add 10 and 20 because they do have the same place value. So it would be 30. And after that, I'm going to add 2 and 3. Again, they do have the same value system, right? 2 and 3, which would be 5. What do I have so far? I do have 30 and 5. So 30 and 5 are going to give me 35. So this is a way about the mental math. Again, it is so easy, yet not that applicable. Imagine that you do have a very, very big number and you want to do that. First of all, you have to break down all of the numbers into tens and ones and maybe hundreds, or again, maybe thousands. And after that, you have to add them up one by one, unit by unit. And after that, you do have this number. Again, you convert it back to the final number. It's not that applicable, but yet it exists. And the final way is about the number line. It means that visualizing the addition by moving right on the number of line for each value added. What does that mean? Imagine that I would ask you to use some kind of line of numbers, for instance, something like this. This is something that we call as axis. Again, right now, we just try to learn the names. Right now, we don't know anything about it. This is just x, okay? And this axis, I would ask you to divide this one into 5 different sections. It means that we will start from 0, like this: 0, 1, 2, 3, 4, and 5. So I just divide down this axis or this line into 5 different divisions or 5 different parts. And after that, I would ask you something. I would ask you that you do have a question. 2 plus 2. So obviously, it doesn't matter if I use the column addition one or the mental math. I know both of them would be 4 if we just do it in my head. But I'm going to visualize it in the system. So the first way, the first step is that I have to put this number, which is a 2, and find it in this axis. So I do have the 2 over here. After that, I have to see how many steps I have to move forward. So at this point, again, you're talking about addition. There's no negative. There's no nothing. You're just talking about addition. 2 plus 2, it means that I have to move 2 steps. 1 step, 2 steps. So I would be here. It means that from this point to this point is 2 plus 2, which is 4. And I know it as number line. So at this point, we understood 3 important ways in order to somehow adding 2 numbers. The first way was about the column addition, which I have to write down the numbers side by side, column by column, based on their value system. And after that, I do have the mental math that we are going to break the numbers into tens and ones, add them up, and after that, again, these are 2 numbers. I have to break them down. After that, add each of those values together based on their place value. I do have 2 numbers, and I have to again combine them together in order to have a number. And at the end, we do have a number line, which is about the visualization. So let's talk a little bit more advanced that how actually I'm going to do this mathematics, because right now, all of the examples that we used was just about the simple numbers, right? 2 plus 2 is equals to 4, and 12 plus 24 is equals a number. So they weren't that hard. But imagine that you're at the condition where your numbers are going to exceed their place value. What does that mean? Imagine that I do have this number, 37 plus 45. So I'm going to add them up. Well, based on what? Based on the first way that I know, which is about the column addition. So 37 plus 45. As I know, first of all, I have to add the units, I have to add the ones, and after that, I have to move forward for the tens. 5 plus 7 is 12, right? This is something that I know. 5 plus 7 is 12. Okay, that's fine, but there's something wrong here. What is that? As we all know, units means that the numbers that you can multiply by 1 and you do have something. These numbers could start from 1, 2, 9, or even the 0 itself. So from 0 to 9 multiplied by 1, I do have a number. Again, that number would be from 0 to 9. As you can see over here, if I combine this with number 12, something interesting is happening, because 12 is a number that's bigger than the maximum number over here, which is this guy is 9. So what is happening right now? 12 contains 2 numbers. As we all know about the mental math part, 12 contains 2 parts. 12 is 110 plus 2, right? It's interesting because right now I do have units that I like it, but I do have an extra 10. What should I do with that? At this point, we do have something that we call as a carrying method. So what does it say? The carrying method would say that at this kind of conditions, when you have a number and that specific number contains a part that it's not going to fit inside that specific value system, you can move it to the next position. What does that mean? I do have 5 plus 7 is equals to 12, and 5, 12, only the number 2 is going to be validated for my work. I like it, but what should I do with that 10? I can carry it around to the next position. Why? Because I know 10 should be in the next value system, not in mine, in the next part. So, okay, we say that we are going to move 1 to the next value system. Then what? So far, we understand that the units part of my final answer is going to be 2. But what about the next one? I do have 4 plus 3, which is equals to 7. So very, very, very simple way is that just write down as 7, which is the final answer, which is 72. But we shouldn't forget that whenever we did the 7 plus 5, we had 1 as a carry number. 1 as a carry number is going to be added up to 4 plus 3. It means that right now I don't have just 4 plus 3. I do have addition number 1, which is going to give me 8. That's why the final answer, instead of just 72, would be 82. The way that we use this guy, the way that we use some extra ones as a number that they are not going to fit inside themselves, is something that we call as a carry method. So carry method is something that we just saw right now, which is about the additional, but in the future, we are going to see that this way is not only going to be applicable for addition part, it's also going to be useful for other parts as well. So we do have some real world applications. What does that mean? It means that, okay, you're doing the adding for what? We are adding for the items in the shopping cart. For instance, I do have the receipt that would be cost $90, and I have to know that $90 contains different kind of parts, 15 plus 25 and etc. I'm going to calculate the money in my bank account. I'm going to combine the receding gradients. I'm going to find the total spent on activities and etc.